Hi, folks. I hope you can find your notes on section 2. We took these notes on Friday, I think it was. So look in your math notebook. If you were gone on Friday, the video is posted. And so get caught up. All right. We're going to focus in on the bottom part down here that you can see. This is the new stuff down here, right? So this is what we did on Friday, I think. And then here we are today. Same section, section 2. So in your assignment, it says, section 8.2, day 2. But we're going to talk about symmetry of functions. So there's really two different types of symmetry in mathematics that we focus on. And that is odd and even symmetry. And I'm going to try to make them as clear as possible. And we're going to look at two about as simple as functions as you can get. Okay, so we're going to look at y equals 4x, y equals x squared. In your Google Classroom assignment, like when you look in here, I'd like you to open that file up on Desmos if you'd like, and you can follow along with me. You can modify your Desmos sketch, and it'll give you some more Desmos skills. How do you type things in to Desmos? So first thing you'll notice is I have a table for my f of x function. I don't have a table for our g of x function. So that's what I'm talking about. We're going to, learn how to make a table and modify it and all that kind of stuff. And your first two homework problems start out like this. What are the x and the y intercepts for our function? Well, this guy, you can see, has, one x and y intercept. They're both the same. It's the origin, right? So maybe this function is too easy for us to see what's going on. And you might say, well, I did this on Friday, Nelson. This was super easy. I just look at the graph. But today, the first two problems, there's no graph. There's just a table. So I want to save you some time. How do you do it if you just saw a table? So let's go +3 just to, excuse me, make my sketch a little bit more interesting so that the x and the y intercept are different. Okay, so you can see like right up here we've got the y intercept. Down here we got the x intercept. Again, you might be saying, I don't need this, Nelson. I knew that. I can just look at the graph. But again, let me say it, in homework there's no graph. So when we look at the table, how do we determine where the x and the y intercepts are? Well, if you'll notice, let's do the y intercept first. You notice the x value is 0 right there. So you can just type in anything you want into the table. So let me just start with 0. You'll notice that it says 0, and then what it's doing is it's putting 0 in for x. So 4 times 0 is 0, plus 3 is 3, right? So that matches up with my y-intercept, right? So if you're looking for the y-intercept, you look for where the x is equal to 0. In our notes, I didn't kind of plan on putting this in our notes, but let's go back up into our area where we talked about x and y intercepts, and let's add just a tiny bit of information here. Okay, so in I'd say the left column, let's put over here, if you had a table of values for x and y, you're looking for where for the x is 0, that would be your y-intercept right here, right? So this number, whatever number sitting here, is our y-intercept. So I don't know, let's put down y-intercept is sitting right here, right? And then if you're looking for the x-intercept, you're looking for where y is 0. That's where the x-intercept is. Whatever this number is sitting right here, that's our x-intercept. So let's look over here. Like if we would have seen in the table for this function right here, we'd have an x, we'd have a y. So let's go for this one right here. We'd have a y value of 0, and there'd be 1, 2. There'd be a 2 in for the x. This is our x-intercept. Okay, and if you were looking for the y-intercept, well, that's the same as that. I mean, the same number, but you'd have a 0 for the x, and then you'd have 2 for the y-intercept. Okay, sorry, I hope that's not too confusing there, because they're both a value of 2. That's how you do the first couple problems. You're looking for, in the table, where is the x 0, then that tells you the y-intercept. Now, this is a little tricky. Like, I don't think I can plug a 0 over here. See, it's not letting me type any number in here. So the Desmos is not a solver, meaning I can't put 0 in for y and have it solve for x. So in that case, yeah, shoot, I can't write on this screen. But in that case, when you see that picture, you're going to need to solve like, shoot, I wish I could. You know what I'm going to do here is I'm just going to find what this is. This is -3/4, right? So if I put over here -3/4, I get a y value of 0, right? So in the table, in your homework, just look for where the y value is 0. That's going to be your x-intercept, right? Where's the y value 0? All right. So that kind of starts us out in the homework. Hopefully you're able to finish the first couple problems. Now let's talk about symmetry real quick. All right. So let's go back. This function right here has neither even or odd symmetry. Okay. So let's put this picture down in our notes right now. Okay. So let's go over here. I'm going to get a picture of this. And let's come back over here, and I'm going to get a picture of this guy right here. All right. So should be over in my notes now. Let's see, where is it? It is right there. Okay. So what I'd like you to do is let's put that way the heck down here. Okay. We'll talk about like, why is this picture a neither odd or even situation? So I'm going to put it like in the middle here. We're going to come back to it. So first, let's look at an easier situation. Okay. Let's take the 3 off there. And I said this is the gasoline example because you're getting charged $4 a gallon for gas. Okay. And it's not realistic because it goes into the third quadrant down here. We have negative values, right? Down here, no gas station is going to take gallons of gas back from you. So we restricted the domain. But today, we're not going to restrict the domain. By the way, when we restrict the domain, that's called the codomain. That's what the author's talking about by a codomain, is when we restrict it for a real world problem. But we're not doing that right now. I'm just going to take that function right there. Okay. And what I want is I'm going to get a picture of that function. So here we go, picture of that function. And we're going to, kind of compare it to that one down there eventually. But for now, let's just put that down in our notes. Okay. So coming back over here, hopefully you got that picture and you got that picture right there. Okay. So if I zoom in on this guy right here, this is y equals 4x, right? Now, what I want to do is I'm going to get a copy of that guy right there, and I'm going to paste it on the screen. So let me zoom out and put it somewhere else. Where did it put it? Oh, it's right on top. That's right. It puts it right on top. Oh, no, it didn't do it. Let's get a copy. Okay, it's been copied. Now I paste it. Okay, there it is. Now we got a copy. Okay, why did I want to do that? Because if I rotate this thing 180 degrees, so here we go. I'm going to rotate it 180 degrees. There's 90 degrees, and here is 180 degrees. Okay, are they the same graph when I've rotated this one upside down from that one? They're identical to each other. So this is an example of an odd function. It's symmetric about the origin. So let's put those words down, please. Symmetric about the origin. About the origin. Okay, so what does that mean? I mean, that's kind of fancy words. This got rotate 180 degrees, and it ends up the same as the original one. Okay, so that's what it means when you just graphically look at them. Okay, symmetric about the origin means odd function. But here's what the author is going to talk a little bit about, which kind of gets a little tricky. So you remember this -3/4, we had -3, right? So if I went -3/4 over here, I went down to -3. Let me point that point out right there. Okay. Shoot, it's not staying on the screen. So, well, I know what we can do here. No, we'll just leave it like that. Okay. So now if I go over here and I put another point in, so let me hit enter. And if you're following along with me on Desmos, that'd be awesome. Let's put 3/4 in. You notice how 3/4 gives us a positive 3 and negative 3/4 gives us a negative 3. So what the author is going to say is algebraically show that it's odd. So right down here, I'm going to show the algebra. So how do we algebraically show it? That's not spelled right. Oh, shoot, man. Sorry, everybody. Let's try that again. Algebra. Okay, so here's the algebraic solution to showing that a function's odd. You take a number like x. You might say, wait, Nelson, that's not a number. And you put it into the function. So here goes x into the function. I get y equals 4x. Now you put negative x into the function. So I go y equals 4 times negative x. And I show that it gives me the opposite, okay, of the original one. So here we go. And see how I've got the negative right there? That means that we've got an odd function. All right. Now let's compare that to y equals x squared. And before I show you the graph, let's just try plugging in a negative x right in here. So here's the original, like when x is positive, I get y equals x squared. If we take the opposite of x, okay, I get y equals negative x squared. Hey, what happens to a negative when you square it? Well, it becomes positive x squared. So this shows that when you plug in a negative, when negative x is plugged in, you get the same function, okay? So we get the same function we started with, same function we started with. When you plug a negative into an odd function, you get the opposite function you started with. So this is how you algebraically show that you have an odd or even function. You're plugging in negative x wherever you see x, and you're seeing what happens. What do you get out when you plug negative x in? So let's look at the even function here. This is my example of an even function. Let's turn the odd function off, and let's turn off this guy right here so we don't see those points. And let's practice putting a table into Desmo. So hit the little plus sign right there, put table. Now, notice it says x sub 2 because we used x sub 1 up here. And then this is the power of using function notation. We're going to put g of x right here. So I'm going to go g, x2, sorry. I hit backspace too many times. Over here, I'm going to have g of x2, okay? Now I'm going to try a number out. Like, let's try out 3, okay? So, okay, I get negative 9, or I get positive 9. Now I'm thinking ahead. I'm going to plug in negative 3. I get positive 9 again. So when I put an x value in, then I put the opposite x value in, I get the same y value that I got when I put the positive x value in, right? Let's try another one. Let's try 5. If I put 5 in, I get 25. If I put negative 5 in, I get positive 25 again. So this is an example of an even function. Now, let's take a look. Notice that each point over here has a matching one on the other side of the y-axis. So what they say for even functions is it's symmetric about the y-axis. That's another way to say you got an even function, is that it's symmetric about the y-axis. Symmetric about the y-axis. Symmetric about the y-axis. So how would I show that graphically? Well, let me get a picture. Okay, so let's get a decent like setup here. And let me go get my picture tool. If you're doing this right now in your notes, you're copying this down, you're doing what I expect. Thank you very much. So here comes my picture of my x squared function. Come back over here. This is an even function. Okay, so check this out. If I take this guy and I make a copy of it, copy's been made. Let's paste it. Let's put it right next to it. If I rotate this guy 180 degrees, oh, it's definitely not the same as the original function. So it's not odd. Okay, so let's flip this back over, like the rotate it back over. Let's do this. Let's reflect it. Okay, so if I flip it over like that, then let's see what happens. So if I flip it over and I want to reflect it like over this y-axis, not over the x-axis. Okay, now do you notice any difference between this one and that one? No. Okay, so this is after it's been reflected over the y-axis. Looks identical to the original function. Now, if we tried that with this one down here, let's try it right now. I'm going to reflect it. It looks totally different. Well, I mean, it's still a line, but it's not going this way anymore. It's going this way, right? So our line was going like that direction. Now it's going like that direction, right? So I'm going to undo that. Okay, so here's my original one. Here it is after it's been reflected over the y-axis, not symmetric about the y-axis. Now let's try rotating it upside down, okay, or 180 degrees. Here we go, 180 degrees. Does it look like the original function? No. So this is an example of a neither situation. They're not always even or odd. This one down here is neither even or odd. Okay? So that's what we're doing a little bit of today in our homework. Gosh, I hope I made that clear. This is a little tricky, plugging in a negative x and all that kind of stuff. That's, the power of function notation. I wanted to say one other thing about that. Remember how we were calling this f of x? That's the same as y, right? Now, if I go like f of negative x, this is what I was trying to do over here. Like if I plug negative x into my function, right? But now this means the same thing. So I get 4 times negative x, okay? And that gives me negative 4x. See, this showed that it was an odd function because we ended up with the opposite of what we started with. And over here, I could have done g of negative x, and then I would have like this, negative x squared. That gives us positive x squared. That's the same as the original function. That means we've got an even function, right? So this one was odd, this one was even, this one's neither. Good luck on your homework.